Hello, ladies and gentlemen. Welcome to today's webinar, Relationship Analytics and Data Visualization for Time-Critical Decisions. I'm Elizabeth Hefner from Sawyer Software, and I'll be hosting today's session. Today's webinar is brought to you by Sawyer Software as part 2 of an ongoing series of webinars examining how different enterprise and government organizations are dealing with data challenges. These challenges are brought on by the combination of growing volumes of complex data and the need to develop actionable insights from this data in a timely manner. In particular, today we are going to discuss the important role relationship analytics and data visualization play in addressing these challenges. Joining us today to discuss this topic from Sawyer Software is Brendan Madden, Chief Executive Officer. Sawyer Software is the leading provider of software for building enterprise-scale data visualization and analysis applications. Joining us from Objectivity are Warren Davidson, Senior Director of Business Development and Strategic Alliances, and Mark Maagdenberg, Senior Systems Engineer. Objectivity is the leader in distributed, scalable data management technology and provides the core technology for Infinite Graph, a graph database system. Gentlemen, thank you for joining us today.
Thanks, Liz.
Great. Thanks a lot, Liz.
Let me quickly go over some ground rules for today. Due to the size of the audience, all attendees will be kept on mute for the remainder of the session. If you have any questions during the webinar, please type them into the question box on the GoToWebinar window on your lower right-hand corner. We'll have a question and answer session at the end of the webinar to cover as many questions as possible. And any that we don't get to, we'll follow up with you individually. Today's session is being recorded, and we will be posting the recording on our website. We will begin today by going over the background of the problem to set the stage for the webinar. I will then be asking Brendan about the role of visualization in relationship analytics and why the partnership with Objectivity was formed. Warren and Mark will discuss Objectivity's focus, the reasons they introduced Infinite Graph, and why it is ideally suited for supporting relationship analytics applications. Then, Brendan will discuss how Sawyer products are used to build applications that leverage data in Infinite Graph, followed by a short demonstration. We will open the discussion up to question and answer after the demo. So let's get started. As the backdrop for the webinar, we all recognize that we are living in an increasingly data-driven world. Recent articles in the New York Times, observations by analysts such as Gartner Group, and reports from Javelin Strategy and Research all indicate growing volumes of relevant information that organizations must sift through to form key insights and aid in decision-making. This data is often complex and can be difficult to utilize effectively. Gartner Group has observed that enterprise data will grow 650% over the next 5 years. Similarly, Andreas Weigen stated that in 2009, more data will be generated by individuals than in the entire history of mankind through 2008. Also, as the pace of business and real-world events quicken, there is a growing need to act on leading indicators in a timely manner to proactively manage threats and opportunities. A report by Javelin Strategy and Research found that victims who detect bank fraud in the first 24 hours were defrauded an average of 1/3 less than those who detected fraud 3 months later. With that background in mind, we will now talk with Brendan Madden about the role of visualization in relationship analytics. Brendan, can you tell me a bit about Sawyer Software and where you started to encounter this challenge of trying to gain actionable insights from very large, complex data sets?
Yes, thanks, Liz. First, we started out in working with in the network management space largely in problems of network topology. That grew into problems of systems management, fraud analysis, in recent times, link analysis, and other areas where there are many entities interconnected, or legal discovery. We've seen applications in the supply chain space, logistical space. We've seen banking problems in CMDB, application landscape, money laundering, and the like. And that's where we're seeing a lot of the client base. Sawyer Software is, is one of the earliest companies in the data visualization space. We started in the early 1990s. We're working 20 years now, and we initially worked a lot with software companies, and in more recent years, we're working a lot with corporations and governments. And so I've been in this field since the mid-'80s, specializing in automatic layout, and that moved on to, visualization consoles, and now we're moving into higher level architectures that move back towards the data. We're headquartered in Oakland, California. We're moving back to Berkeley in about a year. We now have offices in Australia, Munich, Germany, Riga, Latvia, Haifa, Israel, and we're building an office now in Mexico City, where we'll have a development center there. And we have, in the last year and a half or so, we've added a 24/7 support facility that both for software companies that have big network management applications, as well as during development, as well as to keep deployment systems up and running. It's a lot of times in the early years, I would say people when we worked with software companies, they would want the visual applications to help their products sell more easily. The visualization front ends would make a product more attractive. It was unclear why, but in recent years, people they're dealing with they're dealing with great deal of data, and the fact of the matter is when numerous people see the same drawings of data, they can agree on what they're working on. They can agree to make decisions based on the same information, and there's a lot of studies that show people can't understand. They lose where they are in the data if they're navigating off of lists or drop down, or tree controls and the like. And so a lot of applications have migrated, naturally moved towards visual front ends and operation centers and all sorts of systems and network management, all sorts of process applications, data modeling, and the like. So Tom Sawyer's products, we have about a 15 to 20 year experience in API-oriented SDK products. We have 3 lines, and they're across numerous technology architectures, from C++ to MFC, ActiveX, ASP.NET, Java, Ajax products, moving into RIA products and the like. So we have Tom Sawyer Visualization, which are graphical presentation consoles. They have batch interfaces to load data from data sources, interactive diagramming, and event response to respond to user interactions, and as well as viewing, automatic layout, viewing and editing tools that are very smooth, zooming, panning, printing, all sorts of export facilities, image export, multi-page printing, and the like. Tom Sawyer Layout is a product, it's a very sophisticated product line, actually. It's surprisingly sophisticated. It's about automatic layout and numerous drawing styles. We have four styles of layout: circular layout, hierarchical layout, orthogonal layout, and symmetric layout. In all of our styles, we have incremental layout, which is about keeping the mental map of a drawing as you make changes to it. That's a very complex area. We also have rule-driven layout control. So you can specify, what nodes are above other nodes, left to right orderings, groupings of nodes, critical path, kinds of put nodes on critical paths. So layout is about automatic node positioning, labeling, line routing, and the like, and satisfying the specification. Analysis is a graph technology product, and it's you're dealing with nodes and links, graph data structures. It's about clustering, pathfinding, traversals. We have new centrality measures, for the link analysis and government sector. And so we have a great experience in visualization in that area. Those are largely designed for software companies. In the last 5 or 6 years, we've been moving to a higher level paradigm called Tom Sawyer Perspectives. It takes a project-based approach to application design, and the idea is to build a more advanced SDK that takes a great deal of the labor out of application design and development, yet does not reduce the flexibility an application maker would have in building a very powerful and flexible application. So we take this project or metadata-based approach to design of applications, and then we also give graphical configuration facilities and graphical design front ends for complex applications. Next slide, please. What do we really offer? We're trying to give people advanced data visualization technology the way they actually need it. We're used to working with software companies who have very many requirements, so we're taking that kind of experience we've developed and bringing it out to allow Tom Sawyer to work directly with directly with end corporations, directly with governments. And what we do is we really bring, one of the most advanced graph technology architectures, that are available today. We have 20 years of experience across numerous market spaces and numerous technology platforms, and we have a good reputation. And we've learned how to make flexible products to support them so they don't crash, they don't cause trouble in the field, and the like. Yes, so we actually have a number of markets where we sell effectively, or we work with customers, or we have an expertise. We have perhaps 30 or 40% of our customer base is in the networking space. So you're dealing with, there was of course the large growth of the Ciscos and the Junipers and the EMCs and all those companies with large network topology problems. And we became a vendor of choice for the front end consoles. So we have a good experience in network and systems management and process management and supply chain and the like. In the last 5 or 6 years, I guess perhaps driven by 9/11 and other terrorism issues, we've had we've taken a lot of the experience we developed in network management and topology, and taken that into the the link analysis space, into the money laundering, all sorts of issues of people's places and events. And so the problems are in some ways, the problems cross markets, but the scale of the data is growing extreme, and the like. And okay, next slide. So I'd just like to say, we have clients, in the finance space. We have banks, they do application landscapes, CMDB applications, process applications. We have customers in complex event processing, companies in data warehousing, customers like Micromuse and the like in the enterprise software space and telco space. And we've learned to work with, we have a bunch of end user system integrators and the like in the networking space. And in government, we work with some system integrators and the like, and we have some direct clients ourselves. This is probably a very important time to say, why are we working with Objectivity? We're very used to working from in memory from applications, again, working with customers' application data models. We are very good at, scalable graph display, as well as, large automatic layout problems. But there's still the problem like, well, how do you query, how do you store millions of relationships in a data storehouse so you can retrieve them quickly and the like. And so we thought a natural partnership could exist between ourselves and Objectivity, where they are on the scalable server side of things, and we're at the, once it goes from memory to the front end and the like, that's where we specialize. So this is probably a good time for me to transition to the next slide, I guess.
All right, thank you,
Yeah.
Brendan, for that great overview. Let's transition now to Warren Davidson, Senior Director of Business Development and Strategic Alliances at Objectivity.
Thanks, Liz, and thanks, Brendan, for the presentation. That was great info. I just wanted to quickly thank Sawyer Software for putting the webinar together, and everybody for joining us for this hour to learn a little bit about Sawyer and Infinite Graph. So I'll first go into the just a quick introduction of the company, give you kind of a high-level view of Infinite Graph and what we're doing with that. And then I'll transition it over to Mark Maagdenberg, who's our Senior Systems Engineer, and he'll really talk about the things that you're probably most interested in terms of how Infinite Graph works, what it does, the problems it solves. So we'll start by just doing a quick intro of Objectivity. And Objectivity has been around for over 10 years. We've been known as really a company that had the distributed data management system that could really handle complex relationships. And that's what we've been doing for a number of years now. And we've got two products today that we're going to be talking about. We've got two products. We're going to talk about Infinite Graph. Objectivity is our first product that we released years ago, and we sold that to the OEM market and to the government market, and it really established our ability to handle large data sets of complex data. For the purpose of today's webinar, we're going to focus on our new product, which is Infinite Graph. It's a distributed database management system, and it's specifically designed for graph data, which aligns well with the type of information that Tom Sawyer is presenting today. And the other thing that just wanted to mention in terms of the company and what we do is we not only provide really solid products, but we've got an excellent organization to provide services that really can help people from the design and implementation of a project utilizing Infinite Graph. And we also have been really well known within our market and with our customers for having excellent support and service, and it's really been the driving factor in the satisfaction that we've had with our customer base over the years. So let me just start off real quickly by telling you kind of where we've been. We've been in a lot of different markets, from some large Fortune 500 software companies to companies that you may not have heard of that dominate in their vertical markets, to government customers. And you'll find our customers are in all kinds of verticals, from manufacturing to finance to government. There's no real rhyme or reason when you look at the list of customers that we've sold to and who use our product today. The one common denominator, though, is that most of these problems are relatively complex, and the data that they deal with is complex. And these are companies that were not able to solve their data management problems with traditional relational databases. And so they had come to Objectivity, where we had helped design and deploy our product with their products or in their systems to help solve problems that generally are of a complex nature. So moving on to what we're going to talk about now with regards to Infinite Graph. I like to start off with an initial definition, just a very simple idea at a high level of what is Infinite Graph. And so this description from Wikipedia is pretty concise. It stores data that are nodes, edges, and has properties on that information. It also makes a point that I think is a good one to share, because we get a lot of questions about Infinite Graph in terms of, is it a triple store? Is it a semantic graph database? And that really is a bit of a specialized type of graph database. We are a a generalized graph database that can handle a lot of different types of graph structures. So just wanted to get that initial description out there, and so when Mark talks about infinite graph, you'll know what it is. Now the question of why graph databases and why we got there. Well, we'd seen that in the marketplace, and I'm sure everybody here who's on the webinar today is seeing a real transformation in the kinds of data that we deal with. When relational databases were built, the type of data that people were dealing with was really text-based, and it worked really well for relational databases. There's all kinds of examples now where people had to do different things, from Google and Amazon, Facebook, using and building their own databases to solve big data problems. And it really created this whole notion of a NoSQL database marketplace. And graph databases are part of that, but it's got a really specific area. And when you look at the kinds of things that are happening in the marketplace and the type of data that people are dealing with, it's really becoming a very unstructured data world. And the data sets, as Tom Sawyer pointed out earlier, are getting significantly larger every day. Well, as that happens, and some of these unstructured data sets have graph structures, and they're very linked data. If you think about the internet, everything on the internet is linked. So we really think that the graph database market is going to be a tremendously important aspect to any architecture when people are trying to deal with various kinds of data, because it's increasingly becoming unstructured, increasingly getting larger, and increasingly more difficult to pull the information out of that data. And that's where the graph database comes into play. So if we look at the history of where we came from and how we got to infinite graph, we had started to build graph-like structures on applications in a very customized way years and years and years ago for the government. And these were programs and applications that we can't really talk about in a public forum, but it led to our customers telling us there is no other way that we could solve this problem than with Objectivity. And as we looked at that internally, and we said, all right, well, what really are we doing, and what is the market doing? There came a common theme here. This is a graph problem. And so as you guys have seen, obviously, social computing is really taken off in the marketplace. And it's more than just Facebook and LinkedIn. It's really permeating enterprise applications. Everybody's trying to leverage social computing, and social is really linking and relationships. You know, when people are looking at doing analytics, they're now starting to look at heavily linked data. And the government, as I was saying, they're using us to find bad guys, but marketing organizations want to find good guys, and they're hard to find. And a lot of times, it's the relationships and the data that gives you the power to the data. It puts so much more information on that data. But then at the end of the day, once you start to get that data, you want to start to visualize it the way you see it. And that's where our partnership with Tom Sawyer comes in. So when you start to look at that and say, all right, well, why not just a regular database? Well, graph databases are optimized for relationships. And this is what Mark will talk about, how we do this. But it really adds a component to your architecture that makes building a system and leveraging the relationships much more powerful. It'll give the scalability and performance that you require. And if you look at some of these large web properties, everybody will tell you the most difficult aspect of scaling a large site is the database. Well, Infinite Graph can take one of those most difficult aspects, which is the relationship aspect, and give you the performance and scalability, and that's why we built it. And it also, when you start to see how it's built, you'll see that there's a lot of flexibility, and that flexibility allows you to make changes, which can be important in terms of time to market. So when we go into these markets, and they're very similar to the ones that Tom Sawyer talked about, in social networks, in crime, you're really looking for the connections, and you're trying to find the information based on those connections. And we're even seeing customers who are coming to us with applications that are just simple business intelligence, and there's all kinds of links and relationships in that data, and it's very important. So these are all things that Mark is going to talk to you in terms of how do we do it, what are the technologies behind Infinite Graph, and give you some more details to the hows and whys of Infinite Graph. Mark, you want to take over?
Yeah, thanks, Warren. So I'll quickly talk about some of the key technical attributes about Infinite Graph and graph databases in general. A cover the physical storage, query and navigation, and finally look at some of the challenges around distributing that data in a multi-process environment. So what do graph databases really have in common? And the two things I want to focus on here are they're really optimized around relationships. I mean, relationships in our world are treated as first-class citizens. It's not so much storing large physical amounts of data, per object. It's about making sure that you can get to each of these objects through those relationships. So, the navigation part of it's super fast. It has a rich, flexible schema that you can create that describes both the vertices and the edges. The second thing is the graph database typically have a smaller, focused API that deals specifically with things like just adding edges and vertices, doing traversals, index lookups, and so forth. But it's a much smaller API set than you'd find in a traditional database system. Navigation in our world is kind of the new query. Not so much like in a relational world where you'd issue a SQL statement to go and look up a result set and you process that result set. In the graph database world, you issue a navigator which goes and explores the graph and kind of partitions out portions of the graph depending upon the rules that you've defined. And in that regard, the algorithms that you traditionally use against graphs are pushed down at the database level. So you can issue like breadth first or depth first algorithms across those navigators. So I'd like to look at some sample source code here. As you can see the kind of the types of APIs that we support. Go back one there, Warren. So again, it looks pretty familiar to just creating traditional graphs, right? You create the vertices first and then attach the edges to those vertices. So in this case, we have vertices Alice, Bob, Carlos, and Charlie, and we've created edges that represent the types of relationships between those entities. So Alice meets Bob, Bob calls Carlos, Carlos pays Charlie, Bob calls Charlie. Next. If we look at the physical storage comparison to, say, like a traditional relational database and how we store that graph data, it's quite different. In a relational database, you typically store the entities in tables, rows, and columns, and then form the relationships with sort of these join tables, right, that establish how you get to look up those entities. Well, in a relationship or infinite graph, right, the relationships are most important and they're graph optimized. So the relationships or the edges are stored next to the vertices themselves so they can be traversed quickly. Next. So I'll speak a little bit about query and navigation. The queries are much not like your traditional SQL queries I explained earlier where you issue a query and you get a result set back. They're more like an asynchronous navigator that runs along the graph and gives you back results kind of as it finds it. So if we look at the graph below, if I issue a query that says find all paths between Alice and Charlie, right, it's going to give me back the complete graph here. But if I issue another type of query, next here, find all paths between Alice and Charlie within 2 degrees, it's only going to return the ones that satisfy that constraint. And again, if we issue another type of query that limit it to just events that happened in May of 2010, it might only return a certain subset of that graph. Next. So the navigation example is just like the code example we saw earlier. It's pretty simple. All right, we find if we want to find all the relationships between, say, Charlie and Alice, in our previous example, we create a predicate, which basically is a qualifier for the path, and then we create a navigator that looks through the graph data and qualifies each of the paths according to the rules that we've established. And then finally, we start the navigator. So as the navigation runs, it returns results back to the my result handler method there. Next. One of the issues, though, in managing large graph data sets is there's a challenge, right? These graphs tend to grow fairly large. If you think about the types of data that's being stored in these graphs, phone calls, emails, social media events, and so forth, the sheer size of that information continues to grow over time. And we're talking about, in the billions of vertices and edges. So the analytics on that type of data requires us to often look at certain portions of the graph, not the entire graph. And with doing a navigator across or a navigation across that graph, we often need to look at not only what's coming up, but what we've already visited. So what's the answer then? We must distribute the data and go parallel. So the graph is really ideally set up for this type of operation, right? So if we look at the example below, we see that using a breadth-first algorithm, we can split up effectively looking at different parts of the graph and different parts of the code. So this automation can either be, or this navigation can either be automated or guided, as in the previous example. So what happens, though, when we have a large amount of graph and we need to partition that? So in traditional data systems, right, like say in a relational database, you would take a large table of information and you could chart it, right, across different databases themselves on different processing nodes. Well, the same is true for a graph. That is, you would take the graph and partition certain portions of it across different processing nodes. Now, what happens is the result is you get something like in the following, where all the information in the graph is stored on different parts of these processing nodes. So then you don't have the complete graph on any one node. So what happens to the navigator is it needs to be intelligent enough to break apart and to look at each part of the subgraph and bring the results in. So that's why it's important to have a distributed parallel navigator. So one of the key things with the distributed graph, or must-have in this case, is having distributed persistent store. Being able to deal with remote data feeds very quick, because you're getting millions, or not billions, of entities being shoved into the graph over time. You need to have that processing done, not just on one particular node, but across several nodes in a cluster. You need to have distributed navigation across that to get results back in a performant way. And finally, you need to be able to support a flexible data consistency model. That is, the write modes you need to be able to support both a strict writing mode to get back tight consistency, or eventual consistency for those operations that aren't necessarily needed to get back information right away. Okay, next. Okay, if we look at the infinite graph architecture, it's really kind of built on as components. The first component is sort of a core set of APIs that represent the graph functions or methods, right? So user apps are built on top of that core set of APIs. Below that exists a set of sort of pluggable components that represent sort of the housekeeping duties of the graph API. And then next to those are pluggable components that represent things that we can change over time. For instance, on the placement strategy, we can have a single database placement strategy or a multi-database placement strategy in case you want to go out to a distributed processing. And finally, below that is the persistent storage layer, which Objectivity DB works at. So I'll turn it over to Warren to give a summary of the information.
Yeah, so there's your quick Reader's Digest version of Infinite Graph. So if you think about where Infinite Graph plays, it's not designed to really replace your existing data infrastructure. Most of the customers that are working with us today are augmenting their current databases, because they're finding that for specific problems they want to have a dedicated graph database specifically for the graph processing. And what people are also finding is that with the dedicated graph API, it's pretty quick and simple to get up and running with the Infinite Graph and to start building an application on it. And our claim to fame here really is the scalability and performance of the graph database. And so by the architectural design that you just saw, you can see it's got a lot of scalability in it. And that's something that we've been very keen on in terms of where we're going with the product and being able to scale with graph problem set. So that's it for us, and we'll pass it back on to Tom Sawyer.
Thank you, Warren and Mark, for that great overview of Infinite Graph. Now I'd like to transition back over to Brendan. Brendan, can you tell us what is different about Tom Sawyer Perspectives, and why is it the right fit for visual analytics?
Tom Sawyer Perspectives, it offers kind of a visualization middleware to help people work with and bring, so they can make actionable intelligence at the, using a scalable front end. That our technology, our products are very important because most of the other visualization software on the market is quickly overwhelmed. We have some of the most, elegant algorithms, for automatic layout that can scale to tens of thousands of nodes and drawings, and we've worked, sometimes on third or fourth generations of a particular layout algorithm or the like, or even our rendering architectures have been optimized over, 10 or 15 years in certain cases, and so there's a lot of this kind of work. So we've Tom Sawyer Perspectives. What it does is it has built on top of the experience we've had from Tom Sawyer Visualization and moved from the thousands of APIs that an SDK-oriented product has for software companies, taking it up a level to a project-based approach that captures people have data. They have data in data sources. They have application data models in memory. They have, text data, SQL data. They have Excel data. They have XML data. They have application models. And what we did with Perspectives is build the pipeline for customers all the way from the data sources to the front end. And then what we did is capture that pipeline. And so instead of every customer writing the pipeline from data to graphics, we built the pipeline for them. And what we did is we captured all the configuration points in project-based definition of an application. So what happened is this method, it's a project-based approach to application design. There's no code generation. You don't write 10 or 15,000 lines of code to build an application. You can then, what happens is we've built, so the project definition stores basically is a definition of your application. On top of that, we built a graphical, essentially something called the Tom Sawyer Perspectives Designer, which helps you to design projects which are essentially defining the front end of your applications. We decided to go to a design, preview, and deploy architecture. So the idea is you have this rapid, interactive design process to design your application. You then preview it, iteratively as you go, and you make a late decision on where you're going to deploy. You might deploy, you say, I want to deploy to an AJAX application, or you want to deploy to a Java desktop application, or an HTML5 application. So what we've been doing is adding deployment targets to the product line. So we first started with a Java desktop deployment, and so then we went to a single design. Then we went from Java desktop to AJAX, and this summer we'll have the same design will go to HTML5 applications, and later this year, early next year, we'll have same design going all the way to .NET applications. So what we've been able to do is we've been able to take thousands of lines of code and help people capture that in an XML definition of a project. And so then to deploy an application, you only have to write 1 or 2 pages of code. So the one that loads the XML definition and then places the components in an application. Additionally, we, the idea of you don't want to work at the level of a graphical product. You want to work in a data-oriented approach. So Tom Sawyer Perspectives brings the concepts of schema, where you're you're giving us, we have the concept of schema in the product, concept of a separate data model, and schema captures the type of data you're working with, whether it's people, places, and events, whether it's network data like routers, switches, and bridges, and connections, whether it's healthcare data. So you begin to build applications in a data-aware manner. So you have the idea of schema, data model, and then the idea of different kinds of graphical views of the data. What happens is we decided, we wanted to build synchronized views of data and multiple types of views and multiple so that's where the name of the product came from, perspectives, multiple perspectives on your data. So we built a rule-driven visualization system instead of having to code each, to hard code how you go from an application data model to graphical views by writing code and binding each view with in programming. You're able to use graphical a rule architecture to express how you would like the visualization of each view to work. So we have tables, spreadsheet views, diagram views, property views. And we similarly built both a model and a data integration architecture. Model architecture means how you bind to an application's data model and memory. So perspectives can work with with software company applications, model to graphical views. It similarly has a data integration architecture, so it can connect to SQL, Excel, text sources, XML sources, and we'll probably have a special Objectivity integrator, either at the model level or the data. We're working on that. It brings a filtering architecture, and so you can make graphical filters at the front end of your application to turn entities and relationships off in your display based on type or region or location. And then it also, because it's built on top of Tom Sawyer visualization and layout analysis, it brings those core components, but it packages them up more elegantly. And then we're additionally, we have an analysis, Tom Sawyer analysis integrated into the product. So we have that at the API level now, and in the next release in the summer, we'll have a new what we call Tom Sawyer, Tom Sawyer analysis views. They'll be able to do, run a clustering on a data set and bring up the result of that. So, in the visualization sense, we have, we pass through all of our zooming, panning, multi-page printing. So we have a very elegant viewing and editing architecture, drill down, collapse, expand. All of these technologies come together over many years of work. The layout, the incremental layout, the constraint, all those technologies come together to give you a nice front end, and it takes years of work to get it right. So that's what, and just perspectives has taken the level, the playing field up several levels. It was a 5-year effort, and but it didn't rewrite visualization. It uses visualization, so it's leveraged the effort on top of that. Reference architecture. So it can work with many types of so we're saying it can work with structured, semi-structured, or unstructured. You can build you can configure a data integrator if you want to work directly against data. We have you can work from multiple sources of data. It has so it's like data integration or model integration to connect to applications. It has a way to you have attributed data model and schema concepts, rule-driven visualizations, and then navigational features to navigate data sets at the front end. Of course, we have multi-page printing, exporting, both in Ajax and web applications. We have multi-page printing. The things you'd expect in kind of a Visio-like front end, but with a scalable. The main things you need, but I get to work with scalable data sources. The idea is. Now we're trying to do how to selectively retrieve work from a particular node or set of nodes to do dynamic exploration from those nodes. So we're the idea is the Perspectives is beginning to work, as you know, as we start to work with companies like Objectivity. The entity base that's in memory is too large, and people can't load it into memory, so filtering becomes very important. Our own kinds of query facilities become very important, so that we only retrieve what we, customers, there's several levels of query and retrieval of entities, and we're learning, that we have to provide our own additional retrieval. So additionally we're adding RDF integrators now. We'll have that out at the end of June. We'll have RDF query, RDF integrator facilities. But Perspectives itself, the idea is it's because of this project-based approach, we're starting to see it develop into kind of a visualization middleware that shields customers from the technology architecture at some level. So you can build applications, visualization applications, yet you might have been Flex, or you might have been Ajax, and now your staff says, well, we need to run on the iPad now. So you would not have to recode your design. You just need to wait for Tom Sawyer to deliver the next deployment target. For instance, so we went from Java Desktop to Ajax in our version 2. And our summer release we'll have, HTML5, and you don't have to recode your application to get there. And so the idea is customers can begin to work with Perspectives, Tom Sawyer Perspectives, knowing, and then just work with us to know when the deployment target they need is coming. But you can design the entire front end of an application, in a very convenient environment, and get to a reusable architecture that shields you from the next technology wave. So yeah, it's very exciting to see the software run on the iPad, or we'll have it on running in the mobile environments and the like this summer. The other thing that's really interesting, I should say, is Perspectives offers a federated facility. So it can actually the data integration architecture can actually pull from multiple sources into a single data model in memory, and then you can have multiple views of that data. But you can also commit back, and write back, even though there are multiple data sources. So this is a very powerful facility. Many software companies want to go using what we call model integrator, and that's from their application data model to our data model. We give APIs for software companies. We give an interface architecture for software companies so they can implement an interface, and so we have event systems in our data model that customers can their applications can catch events and do processing on the server and the like, and and over the years our overview technology, our zooming, our drill down, go to child, go to parent, our into incremental layout and rule-driven layout and routing work very well. To when you're working with large data sets, if you want to fold a set of objects, hide a set of objects, and all these kinds of facilities work very well with filtering and the like. So you can filter some objects out, do an incremental layout, reduce the complexity of the view, and and then so there's all of there's 20 or 30 different kinds of technology that come together to make this all be a nice experience. So you have a designer. So the idea is Tom Sawyer Perspectives offers a project-based approach. We put a designer to help you build these projects. The designer has schema, integrator definitions, view definitions, and filtering definitions. Next 10, yeah. And the idea is we offer a prepackaged previewer that you can design a project with tree controls, diagram views, spreadsheet views, and the like. And the previewer lets you see, the current project you're working with, and you can preview it at any time. So that's an example of a desktop preview. And that as you build the previewer, you're actually working with your real data. You're working with the structure of the data you actually have. So it's a very powerful. Don't don't assume because as a graphical designer that it limits you. It doesn't. It does package up and implement common patterns and the like for you, but it's still an SDK, and that's a really key point. It's just that it's a more advanced kind of SDK, and it reduces the labor, and the value of this architecture is that if you look at application lifecycle over 5 or 7, we have customers with 10 and 15-year-old apps now, and some of them are stuck back 4 or 5 versions ago because maybe some engineers quit, maybe it was too much work, didn't feel like upgrading. The idea is, instead of having to, port code, to a new release of Tom Sawyer, you just open up the project and save a new version of the project, much like you do with Excel or with Word. You open a Word file and save the new format of Word, and you've actually upgraded your application. So you don't have to. We shield all that. We shield you from all that. Tens of thousands of lines of code that have to be recompiled, and you can build Ajax and HTML5 application. Ajax now, HTML5 this summer, and and web desktops. You can decide how to you do a design, and then you make a late decision where you're deploying it to. Okay, so the idea is you code it once and you're shielded, and it actually works. Yeah, I think so. So the idea of this slide, it's the idea is design a project that works with your software platform or where all your data sources are. The project then gives you the front, all of the definition, your toolbars, your context menus, your graphical, if you, for instance, said I have a table and chairs. Well, I could draw a table with, you could draw a tree diagram. You could put the chairs inside, a table node. You could have different kinds of ways of looking at the same information, and you can capture all that kind of structure in a perspectives project. And so here you can see at the top, the same application will deploy, to a desktop Java app, an Ajax application to the iPad. And you're getting the latest rich internet, RIA application front ends, and we also have a terrific rendering architecture that helps you work with scene-based representations of the drawings of nodes and links, and that's a portable representation of the graphics. For the graphical elements and all the drawing elements, and the idea of that is you can build style sheets and structure, the visual appearance of your drawings and the like, but in a rendering neutral fashion. You don't have to worry that it's going to be in an Ajax application, but it still looks like the same node on the screen, and it still behaves the same at the front end. It's just that in one case it'll be Ajax, in another case it'll be Java Desktop or .NET. So we've been working a lot on this in this direction. Okay.
Okay, thank you, Brendan, for that great overview of
Okay.
perspectives. So now
Sorry,
Brendan is going to do a demonstration showing Tom Sawyer Perspectives SNA capabilities.
Yes. So first I just wanted to just give a little bit of, before I go into perspectives, I just wanted to show a little bit about scalability. This is a Tom Sawyer visualization Ajax application. So I'd just like to show that's a circular layout on the screen with 1,500 nodes, and I just recalculated it with symmetric layouts in about 2 seconds. And you can see something like undo, redo, so that redo actually recalculates the drawing.
Brendan?
Yes, please. Yes.
Brendan, are you showing your screen? Are you showing your screen?
I apologize. I didn't click the button.
No problem. Thank you.
So I would just like to, so here's an example of an Ajax application. I just wanted to, show you with a little bit of the core architecture. So this drawing has 1,500 nodes and 1,500 links, and so you might say, well, and it's pure Ajax, and you might say, well, gee, how how fast would the layout, does Tom Sawyer scale? So I'm just running a symmetric layout here. It's running on a local Tomcat instance on my computer, and it's about 2 seconds for the drawing to calculate. The drawing is rotated to fit on the canvas properly. It's got an optimal rotation, and then a rendering in the browser. So you can just see something like this, zoom in, marquee zoom in, zoom out. So that's just an Ajax example. Then I'd like to quickly show the Java desktop example. So this is, I'm starting with a random layout. Then I'd just like to show, I'm running a hierarchical layout now. So I'm just calculating that. So just to show you the kind of quality of the drawings you might expect with Tom Sawyer. And so I'm zooming, so you can see this is a kind of like a supply chain style of drawing with, you can see, so marquee zoom, overview facilities on the right. This is a directed left to right. So you can think of this like a logistical drawing or a process or a supply chain. So that's an example of hierarchical layout. I'll take the same, calculate a different drawing with animation. So that's a symmetric layout of that. An orthogonal layout has degrees of freedom in the X and Y direction simultaneously. We've also, in the most recent years, added cancel, multi-threaded drawing facilities and the like. So each canvas can render independently of another. So I just like to show, zooming in on this. So we have nice automatic labeling. Nodes, links, and connection points can all be labeled. You can have multiple labels. So in our software, you have, full control of, the appearance of nodes, appearance of links, background colors, all the things you'd expect to be able to change, context menus on nodes and the like. So this is our visualization architecture has viewing tools, editing tools like all sorts of diagram facilities, deleting nodes, moving nodes, resizing nodes, everything very powerful for modeling applications. And then we take that up a level with perspectives where visualization becomes a component. And so this is an example. So what in this example, I have opened the Tom Sawyer Perspectives Designer. And the idea of this product is you have the idea of the definition of your data is the concept of schema. In this case, this is a networking data set I'm working with. It's, think of it like classic network management, devices, connections. Devices have status. You have the types of devices. You have maybe what building they're located in and whether they're West Coast or East Coast and the like. So that's in the structure, the definition of the data. Here is an example where the data is coming from 2 data sources. So it's an example of what I was mentioning, the federated data. We have the idea of devices and connections in one Excel definition, and status definition in another. Then we have the idea of the graphical views we'd like to have in the application. So in this, so this is actually the Perspectives Designer. You can actually incrementally or interactively create new drawing views, new tree controls, new tables, and the like. But this is a pre-made one where we say, well, I want a network map in my drawing. I want a tree control. I want 2 table views, which is like a spreadsheet, something to show my events and the like, some graphical inspector, on a per node or per link basis, and some filters. So the idea of perspectives is, okay, I can define this application. So, and you can see, for instance, for an application, you could say, well, what is my default toolbar setup? So you can actually, the bottom to top drawing, the top to bottom drawing here gives me the left to right toolbar for my application. Similarly, you can define the context menus. You can launch programs off of nodes. You can make custom actions. You can write code and the like if you want to. And so the idea of perspectives is at any time you could say, I've designed my application. Now I can say I want to do a desktop preview, or maybe I want to do a web preview of that. So I'll do a desktop preview. So here, that loaded the data from the 2 data sources and displayed it into the front end, and we didn't have to write any code. So all we had is this design. That what Perspectives offers is a synchronization architecture. So here you see on the left I have a tree control view. It's a configurable view of the data again. I have a drawing view and that's also configured. And then I have a spreadsheet view that's also configured from my data. So you can say what do I want to show in each column, and then how do I want each cell in each column to render. So for instance, if I select a particular cell, Perspectives offers a view synchronization architecture where each view can synchronize all the other views. So the bottom over here, you're seeing the set of attributes and values you want to show against a particular node, or similarly with a particular link, I may only want to show capacity and the connection load. You can say what I want my tree, I want my tooltips to display. You can configure how a tooltip should appear. And then again, they all work against the data that's defined in your application. But the idea of Perspectives is, so you can then, you can run your automatic layouts against your data, against your drawings. And Perspectives offers, you can configure your graphical controls to say, you can make a tree control behave like a legend, and you can similarly define filters to work against your data. So if I go back to like the symmetric view, I can say, well, I want to define certain kinds of filters. So this tree control, I've said define regions, device locations, and device types, you might say. So these are very traditional things you would want to do in an application. I don't care about my phones or laptops or printers, so everything responds dynamically in each view. Similarly, we configure this tree control to act like filters. So to give you grouped views. So I want to say, give me a nested view by region. It's generated a new graphical view. Give me one by location. So now it's grouped them by building. So the idea is this dynamic front end can be written in a few hours compared to months and months of work. And let me just briefly, 1 second, show the same application running in the web. So this is a GWT-based technology, and you can build GWT-based web applications, and you get the same kind of technology all in the web. This is an AJAX-based implementation, but it behaves the same as the desktop application. With all the same technology, overview windows and the like. But you design one to deploy to several locations. Briefly, I just want clusters in a network. This one has 7 clusters, and we color code them. You could say, what is the root cause? If I have a whole dependency graph and I have some effects, the effects nodes are yellow here. What are the causes potentially? And these red nodes say there are 14 possible root cause nodes in this data set that you have to check. We've also just added new centrality measures to the product. So these are often used in the link analysis space. So we've added, for instance, eigenvector centrality, and this show calculates the darker the node, the more central. In this case, we've added closeness centrality is another type of centrality. It shows the darker the nodes mean that the dark nodes are closer to the other nodes based on the cost and capacity. Another type is something called betweenness. It's an example where the dark nodes are on multiple paths, are on the most paths between all the other nodes. So that's like the man in the middle problem. Who knows the most? Where is the information flowing through the network? So these blue nodes here. So we've added a whole series of so it's clustering, network flow, path finding. Sorted paths is another example. It tells you all of the paths between a start and a finish node. And this example says there's 24 paths between the start and the finish, and you can iterate through them by clicking, so the paths are growing in length from 21, 25, 26. they're getting so there's advanced technology here in the graph theory. There's about 30 algorithms in the analysis, and that's being integrated into. It's already integrated at the API level and perspective. And the next release will have it at the front end. So I guess I'll just say thank you to Objectivity folks, to Warren, etc., and I'll transition back to you, Liz.
Thanks, Brendan. That was a great demonstration. We're running short on time, so we're going to answer any questions that we received today via email. So as we end this session, I'd like to encourage you to visit the Visual Insights blog, which is sponsored by Sawyer Software. Visual Insights is a great place to exchange opinions, ideas, and knowledge about all things data visualization. Also, please visit Objectivity's website for the latest announcements on their company, events, and products. Objectivity will be at the Counter-Terror Expo, a globally renowned event for counterterrorism professionals, April 19th through 20th in Olympia, London. Also, Sawyer Software will be exhibiting at Interop Las Vegas this year. Visit our booth to see demonstrations of the latest visualization and analysis technology. You'll be notified by email when today's webinar is available on our websites. Stay tuned for more announcements from Sawyer Software about our ongoing series of webcasts. Our next webinar will address data challenges faced by the financial services industry. I'd like to thank our speakers, Brendan, Warren, and Mark, for a great session today. And on behalf of Sawyer Software and Objectivity, I'd like to thank our audience for joining us.